first interaction technique is raycasting. Multiple objects can be selected and positioned via controller input. The control scheme for the raycast in this application is analogous to the mouse and keyboard input scheme from a desktop computer. The X button on the left controller acts as the control key on a keyboard. The right-hand index trigger acts as the left mouse button. To better get to know this control scheme, a short tutorial showcases the usage. To select an object, point at it and press the index trigger on the right controller. To select multiple objects in a row, point at one, hold the X button on the left controller pressed and press the index trigger on the right controller. To change the position of objects, select multiple, point at a certain target area and press the A button on the right controller. These interactions will be sufficient for the following application. The second technique to be compared is the manipulation of objects via speech and gesture. Multiple objects can be selected at once and positioned with the help of multimodal commands. In this application, it is possible to manipulate objects through unimodal as well as multimodal commands in form of speech and gesture. The interaction is designed to be as natural as in everyday life. To get an understanding of how it is implemented in this application, the following sequence demonstrates the usage. To select an object, point at it and say "Select that box." Select that box. To select multiple objects, say "Select all boxes." Select all boxes. To change the position of objects, select multiple, point at a certain target area and say "Put all boxes there." Put all boxes there. These interactions will be sufficient for the following application. For selecting multiple objects with subsequent teleportation, speech and gesture is more time efficient than raycasting with a multiple selection and teleportation functionality. Speech and gesture control is more intuitive than the specified raycasting. Users prefer a speech and gesture control over the specified raycasting. Cognitive load is lower with speech and gesture control than with the specified raycasting. Speech and gesture are interaction techniques which one uses in real life for everyday tasks. This natural way of interacting with objects in a virtual environment could keep the cognitive load comparatively low and could lead to a better performance on cognitive tasks. For building applications with an VR editor, this additional input method could contribute to a more time-efficient way of working. A within subject design has been chosen. Each participant takes part in 10 consecutive trials per condition, with the items positioned at different locations. The order of conditions is randomized. In separate training sessions, the participant gets to know the environment and receives a brief explanation of possible commands to interact with the present objects. The training is continued until the user feels confident with the technique. Select all tires. Put all tires there. Before the first trial starts, the participant is told that he'll be asked questions regarding objects in the shelf after all 10 trials of one condition are finished. For example, how many pipes did you see in the shelf? These questions are intended to measure cognitive load. The participant has to select multiple objects of the same type and place them at the specified target location quickly. The task has to be performed with speech and gesture control as well as with raycasting. Select all boxes.
Put all boxes there. Select all tires. Put all tires there.